Assalamu alaikum warahmatullah. This tutorial is about sound, which is the part of SSC Physics Wave and Sound chapter. So in my previous videos I explained about wave, and if you understand all the series of videos that I have uploaded in the playlist of sound and waves, so that this is the fifth tutorial I think after the series of wave. And in this tutorial I shall discuss about the definitions, the characteristics and the topic that should be covered when we'll study about sound. So think about, we need to study about characteristics of sound and the reflections, then echo and the speed of the sound, also the use of echo, then musical sound, and last of all we need to study about the sound pollutions or noise. So what is sound? Right now I'm talking. So that sound is producing through the vibrations in my vocal cord. So if I touch my throats, then I will feel that when I talk there are some vibrations is going on there. So my vocal cord, there are some membranes that is always or continuously vibrating, and then the sound is producing. So we can say that the sound is a wave that is created from the vibrations, and then it propagates through an elastic medium. So simply we can say that sound is a wave. So it's created or it's demonstrated from the vibrations. So when there is a vibrations, then it creates sound. So, and that sound should be propagated through an elastic medium, and that medium can be air, that medium can be liquids, and that medium also can be metal. So primarily we can say that sound is a mechanical wave, and also sound is a longitudinal wave. So firstly we can say that sound wave is actually mechanical wave, and also we can say this is longitudinal wave. Why? Because when sounds propagate, we need to know that how the wave transmitting particles is oscillating. So in the types of wave, you know that there are two types of wave, which is transverse wave and longitudinal wave. In case of transverse, the particles, the wave transmitting particles propagates or oscillates perpendicularly to the directions of wave, but in case of sound it propagates parallelly to the directions of wave. And how it's doing, like if you see a tuning fork, which is very simple example of producing sound from the vibrations, which is available in the physics lab, then if you just strike it, then the vibrations will happen, and if you see, if you just put it in your ear, then you'll feel the sounds is going on, and whenever you make it stop, there is no sound is producing. That means all the sound is producing from the vibrations. So when it vibrates, what's going on? When it vibrates, then the other parts, the part of it is actually vibrating in this way and in this way. So when it's vibrating this way, in the surroundings area there are some, air. So the air is an elastic medium, and then air transmits or propagates these sounds from here to the other places. So suppose if there is a person is standing there and the distance is there, so we say that the air is propagating or oscillating like this. So when we can say that sometimes it's propagating like this, that means in some cases there is a contractions of the particles or the medium, and there is a rarefactions. So from the concept of longitudinal wave, we know this is the contraction or compressions. We can say that this is compressions, and this is actually rarefactions. So through these compressions and rarefactions, or you can say expansions, the wave is propagating or transmitting from one place to another place. So if there is no medium, then no sound can be propagated, or sound wave won't propagate, because there is no medium. So in the absence of medium, sound will not propagate. So as a medium is required for propagating sound wave, this is called mechanical wave. And as the wave is propagating through the rarefactions and compressions in a medium, it can be in solid, it can be in liquids, and of course in air. That is why it's known as longitudinal wave. So how we can say, or how we can define sound? We can simply say that sound is a wave that is creating from the vibrations and propagating through an elastic medium. So this is sound. Now we think that what are the characteristics of sound? So the characteristics is like it's a mechanical wave, it's a longitudinal wave, and a medium is required. Medium is definitely required. So think about it. Now we need to think about the speed of velocity, the velocity of sound. So speed of sound. So, or we can say the velocity of sound, because speed and the velocity, you know the difference is speed is a scalar quantity and velocity is a vector quantity, because the velocity, it has a directions. So in case of the understanding or the conceptualize the velocity of sound, we need to think or need to consider that it has a direction. So what is the speed of sound or the velocity of sound? It means the times or the distance traveled by the time. So d means the distance. So we can say the unit of the velocity is meter per second. And this velocity is actually a vector quantity because it has a directions. So when sound is creating from the vibrations, it propagates through a specific directions, and that is why we will consider velocity of sound instead of the speed of a sound. So I hope you understand this is v, which is actually the velocity, is very common concept, the distance traveled by the sound divided by the time required, which is meter per second. Now you think, what is the nature of velocity of sound? The nature of the velocity of sound depends some factors. That is, the velocity of sound depends on factors. Number one is temperature, and number two is the density of the medium, and it also depends on the humidity of air. Now how to think about it? Usually what is happening, like in 0 degrees Celsius, in air, in STP, like in standard temperature and pressure, that means in 0 degrees Celsius and in 1 atmosphere pressure, the velocity of sound in air is usually approximately 330, 31 or 32. That means 332 meter per second. In some books 331 is written, or even 330 is written. So I hope 332 will work. So in 0 degrees Celsius, 332 meter per second is the velocity of sound in the air medium. Now you think, what is the velocity in 30 degrees Celsius in air, which is actually 350 nearly meter per second. Now you think that when temperature is increasing, the velocity is increasing also. So if we say the differences between the temperature and the increase of the velocity, we will find a relation, which is that when temperature rises from 0 to 30, so in 30 degrees Celsius, when it increases, the velocity increase 18 meter per second. That means in 0 degrees Celsius it was 332, when it is 30, then it becomes 350 meter per second. Now if we deduct, then we'll get 18 meter per second. Now we can have a conclusion that if 30 degrees Celsius is the increment of the temperature, that if the velocity is 18, then per degree Celsius temperature it increase it increased 18 by 30 or 0.6 meter per second. 0.6 meter per second. So this is the velocity that is increasing per degree Celsius temperature. But if you see the velocity of sound in liquids or in air, we can say that in air the velocity is nearly velocity of sound in water. In water, then we can say it's more about like 1450 meter per second approximately. And the velocity in iron, which is actually metal, so velocity of sound in iron, it's nearly 5221 meter per second, nearly. So this is the approximate value to give you understanding that what are the changes. You see that in 0 degrees Celsius is 332. In air, in liquids, in water, it's 1450. Even it differs in case of water of pond or in case of water of ocean. So in marine water the velocity will definitely increase, is because in marine water, this is salty. That means the density of marine water is higher than the normal water. So I hope this will again increase in case of marine water. And see, the metal is 5221 meter per second. So I hope you understand the relations between the increase of temperature and increase of velocity. There is an equations. The equation is the velocity is strictly proportionate to the square root of the temperature. That means V is proportional to root over T. This T is the temperature, but the unit should be in Kelvin. How to determine it? So we know the velocity is directly proportionate to the square root of temperature in Kelvin. So we can say that the velocity in a single medium and in a different temperature, it will be like root over T1 by T2. And this is the principle, or this is the equations that we can use, or we need to use to determine the velocity of sound in different temperature. How to determine it? So I'm just giving you an example. Suppose that in 0 degrees Celsius, which is equivalent to 273 Kelvin, the temperature is, suppose I just put it down to 332 meter per second. Now I say what is the temperature would be in 40 degrees Celsius, or 273 plus 40 Kelvin. So this should be like 273 plus 43. This is 313 Kelvin. So what should be the velocity of sound in 40 degrees Celsius, where the velocity is 332 in 0 degrees Celsius? Now I think about these equations. How to use it? We can use that V1 by V2 is equal root over T1 by T2. That means V1 is this. So 332 by V2 is equal, T1 is the temperature, is 273 divided by 313. So we'll get it. So if I divide the root over 273 divided by 313, then we'll have 0.93. So we got it, 332 by V2 is equal 0.9339. So if I say the V2 is 332 divided by 0.93. So if I divide 332 divided by answer, so it's like 355.49 meter per second. So we can use these equations to find the velocity of sound in different temperature. So we took it as standard value that in 332 the meter per second is the velocity when it is 273 Kelvin. So we need to put it that Kelvin is the standard value here. When we need to think about these equations, we need to put the unit of temperature in Kelvin. Now we'll think that how you can use it in a different form. We said that per degree Celsius, velocity increase 0.6 meter per second. So we also can use another formula that V theta is equal V naught plus theta times 0.6. This is another equation, so you also can use it. How? Suppose the previous equations like 40 degrees Celsius. Now we are searching for that 40 degrees Celsius temperature. This is 40 degrees Celsius. So we know that V naught is 332 meter per second. That is, V naught is the velocity of sound in 0 degrees Celsius. So plus theta is the temperature that is increased is 40. So we have 40 times 0.6. So we can say that what should be the value? 40 times 0.6 plus 332, which is again 356 meter per second. You see the almost similarities of the data, that is 356 meter per second and 359.5 meter per second. So we can find out the velocity in different temperature in both ways. It's up to you. Suppose in 2020 physics book here is given like this, so we can use it also, or you can use it very simply, because when we'll try to solve some mathematical problems in case of sound wave, then we must consider this. We need to find out the different velocities given in different temperature. So I hope you understand it, hopefully. So what we actually studied in this tutorial, I said about the definition of wave, I said about the sound wave, the characteristics of sound wave, and the velocity or the speed of sound in different format or different medium. So we need to think about that the velocity of sound will be 0 when there is no medium. So if somebody is thinking about the moons, if two bodies are standing together in a moon where there is no medium, if they started to talk, they won't hear anything, because between them there is no medium to propagate the sound, as because sound is a mechanical wave. So at least an elastic medium is required to propagate or to transmit the wave from one place to another. As it's a longitudinal wave, it definitely is a combination of rarefactions and compressions of the wave. Through this it's propagate. And most importantly, comparatively, the velocity of light and the velocity of sound. If you see, the velocity of light is nearly 3 times 10 to the power 8 meter per second. Or if you see in 30 degrees Celsius in air, the velocity is 350 meter per second. Now we think there is a huge differences between these that we see usually in case of thunderstorm. So when thunderstorm is going on, we see the light flashings in the sky, and after some time we hear the sound boom. What does it mean? It means that we see the sound, but in that level, sound and the contractions of the clouds happens together, but light comes directly and come quickly because the velocity of light is so high than the sound velocities. And so light comes directly and quickly, so we can see the thunderstorm lightings there, but after some time, a little bit sometime, we hear the sounds. Even when we are watching cricket, playing cricket game in the stadium, when you are watching that the player is striking the balls through his bat, and you are watching from like even 50 meter or 60 meter, even 90 meter, then you think that when the batsman strike the balls, after a few seconds or after a few moments, you are hearing the sound of the striking ball. Is because that you are watching it, so the light's coming directly and quickly to your eyes, but the sound's coming to your ear after some little of duration. So that is why the velocity of sound is comparatively very less than the velocity of light. So there are some practical examples that why we are actually experiencing in a day-to-day life. So I hope you understand the definitions, characteristics and some sort of explanations regarding sound wave. I'm coming up with the next video, the reflections and echoes, and also the use of echoes, which is very important concept of this chapter. So take care, see you next, bye.